the last video and that I'll be sending you, and also the last topic to be included for your final exam. So we're going to discuss about ethers, epoxides, thiols, and sulfides. So basically, ether has two organic compounds. You have aryl, alkyl, or vinyl bonded to the same oxygen atom, ROR prime. So ganito yung mukha ni ether. So this is the R group, the first R group, RO, and then the R prime can be in other different form. So this is an alkyl. You have this alkyl group. It can also be aryl, such as this one here. So this is a benzene group, which is the R group, and this is the methyl group, which is the other R group. So this is anisole. And it can also be like this. So this is your R group. Basically, so kebali, you have yung oxygen mo inside your ring. So here is your diethyl ether. It's called di because you have two ethyl groups. Then this is an ether. So diethyl ether is used industrially as a solvent. And then here, you remember CTHF. This is what you call tetrahydrofuran. It's a solvent that is a cyclic ether. And aside from ether, you have your thiols and sulfides, which we are going to discuss today. So to finish covering the functional group with CO and CS single bond, we need to discuss this topic. Focus on ethers, and then after that, we can then it's easier for us to discuss about thiols and sulfides since they have similarities with respect to their structure. However, instead of oxygen for ether, you have sulfur for thiols. So how will you name and classify an ether? So in naming your ether, it's very simple actually. So you need to determine the two organic compounds on that will act as the R or is the R groups. So you just need to determine ano yung mga R na yun para mabigyan mo ng name yung ether mo. If the other functional groups are present, the ether part is considered as alkoxy substituent. So instead of ether, basically, yung ether mo na will act as a substituent mo siya. Substituent mo na. Kung meron kang other functional groups that is present in your compound. So ROR is a tetrahedral bond angle. It has a tetrahedral bond angle, which is 112, specifically for dimethyl ether. And oxygen is an sp3 hybridized. Oxygen atom gives ether a slight dipole moment. So that's why, because yung oxygen mo, meron siyang dalawang lone pair. So ito, wala siyang ibang functional group. So that's why it's called ether. It's not, the ether will not act as a substituent. So you have this isopropyl. This is your isopropyl. This is your methyl group. So you call it isopropyl methyl ether. This is your phenyl group naman, and this is the ethyl. So that's why it's called alphabetical pala ha. Ethyl phenyl ether. Now you have two functional groups here. That's why it's already called ethoxy, specifically ethoxy. So you have ortho, meta, para. Sorry, ortho, meta, para. So that's why it's called para. You have two. This is methoxy, since you only have one methyl that is attached to your oxygen. So that's why it's called dimethoxybenzene. Now, dito naman, sa last example, you have here on the right side, you have tertiary built because you have four carbons and it's tertiary. The central carbon which is attached to your oxygen has three carbons attached to it. That's why it's called third. So four, since if we so if we start counting in your alkene group here, so 1, 2, 3, 4, so on the fourth carbon of the ring, there's the ethoxy or apologies, butoxy group attached to it. So it's called 4 third butoxy. Then this is the main family name. So you have one, because you have the ball bond here, so one cyclohexene. So that's how you name them. And in synthesizing ether, it's prepared by sulfuric acid catalyzed dehydration of ethanol. So you need to have ethanol first before you can synthesize an ether. So you need to use this dehydration process because you need to remove water. Or you can also do the Williamson synthesis. Williamson ether synthesis. So this reaction of metal alkoxide and primary alkyl halides and tosylates. So you need methyl alkoxide. And then you need a primary halide, primary alkyl halide, and tosylates. So best method for preparation of ethers is the Williamson ether synthesis. Alkoxides prepared by reaction of an alcohol with a strong base such as sodium hydride. So you to prepare an alkoxide, this is an alkoxide ion, you need to use a strong base such as sodium hydroxide in a THF solution. And we're going to discuss the reactions that occur on ether. So you first have your acidic cleavage. So here, so basically yung ether daw, they are generally unreactive. However, if you have a strong acid, they will cleave through your ether, and it should be at high temperature. So if, for example, you have your HI, your HBr, it will produce an alkyl halide. So like, for example, you have your HI. If you react it with your ether at a high or elevated temperature, it will undergo a SN1 reaction. If it's primary or secondary, it will undergo SN2. But if it's tertiary, it will undergo SN1. So this is the product. You have an alcohol. Then you have your iodoethane. Here's another example. If you have ethyl, this is the ethyl group, and then you have your phenyl ether. So you will react it with a strong acid such as um, bromic acid. So you will produce an alcohol, phenol, specifically the phenol. It will cleave through your ether till you produce the phenol, and then the halogen group will attach to the other substituent or the other R group. So you will have your bromoethane. And this is also the appearance of a cyclic ether. So cyclic ethers behave cyclic like a cyclic ethers, except if ring is three-membered. So this is an example. You have dioxane and tetrahydrofuran, which are used as solvents. And then you have epoxy rings naman. So yung three-membered ring, that is what you called oxyrane. So another term is epoxides. You call that epoxides. So this is an example. You have ethylene oxide. You can synthesize ethylene oxide from ethylene at high temperature using silver oxide catalyst. And then this is how you prepare epoxides. I think this was already discussed to you during your prelim topics. So you treat an alkene. For example, you have your alkene here. This one is what you call cycloheptene. You treat it with a peroxy acid. This is already discussed to you. So you will form your epoxide or the three-membered ring compound. Can also create epoxides from halohydrines. So you can produce halohydrines after, if you have your hexene or you have your alkene here, you can react it halogenation process, hydro halogenation process. So you will have your halohydrines, and then after that, you can react it with a strong base such as sodium hydroxide, and then you will have your epoxide. And these are the reactions of epoxides. So usually, if you add water with dilute acid at room temperature, there's reaction. It's what we call the ring of opening reaction. So the ring will open. So your three-membered ring will open. So this is one reaction of epoxides. It will produce one two diol. So it will go back to its alcohol form. So ito, si diol. Dapat adjacent yung dalawang alcohol mo. Dapat katabi yung carbon nila. You can also produce halohydrines. You go back to yung halohydrine form niya. Kung you can use anhydrous, may walang water na acid. So like for example, HF. So itong halogen na to, siya yung mag-co-connect or siya yung mag-replace sa other adjacent carbon. So you have your bromine, bromic acid, hydrochloric acid, and then you have your iodic acid para makagawa ka or makasynthesize ka ng halohydrines. So when both epoxide carbon atoms are either primary or secondary, attack on the nucleophile occurs primarily at the less highly substituted site and SN2-like results. So when one of the epoxide carbon atoms is tertiary naman, however, nucleophilic attack occurs primarily at the more substituted site, which is why you have this like an SN1 reaction. So again, when both carbon mo sa epoxide, like for example, ito, wait, no, I'm pointing at the correct carbon. So like for example, itong carbon na to and this carbon na to, so either primary, so itong isa is primary, yung nasa right, yung nasa left naman is secondary. So if either primary or secondary daw, yung nucleophile mo during the opening of your epoxide to form halohydrine using an acid, a strong acid, anhydrous acid. So basically, yung nucleophile mo, it will attack the less substituted. In this case, it will attack yung primary because it's less substituted. So dito, pupunta si chlorine mo and then yung OH mo is this is our left, of course. So ito yung majority. And if yung isa is tertiary naman, of course, yung mangyayari is SN1 kung yung isa sa kanila is tertiary. So, kung si SN1, yung nucleophilic attack, it will occur at the more highly substituted. So, in this case, si tertiary. So, dito si Cl, mag-bond. In this case, ito yung product, majority of product. Dito naman sa right side, si hydroxyl group. So, assignment naman, I will take notes as well. So you have 3 assignments to be submitted this Monday, May 19. So you have 2 assignments from the previous video. Then you have 1 assignment here. So you will be going to predict the majority product of each side reactions or each reactions. Or your epoxy. What's the reaction of this? Epoxides. Let's proceed. This is as a short discussion only. So, unlike other ethers, yung epoxide rings mo, it may also cleave using bases and nucleophiles, as well as acid, although an ether oxygen is normally a poor leaving group in an SN2 reaction. So, the strain of your three-membered ring, it causes epoxides to react if you have your hydroxide ion at especially at elevated temperature. So yung base catalyzed epoxide opening is typically an SN2 reaction in which yung atake ni nucleophile mo or yung base mo dito nucleophile, I mean yung base mo pala, yung attack ni ay nucleophile. Okay, so yung attack ni nucleophile mo takes place at the less hindered epoxide carbon. So like for example, less hindered, so dito siya sa right side. This is the base catalyzed epoxide. Kung gusto mo i-open yung ring mo, you can use this reaction. You're going to use strong base or you're going to use base. So si base, para ma-open niya yung ring, doon siya mag-aatake sa less hindered or less substituted na carbon. So this is an example. You have 1, 2, ito pala. So dito, so this is an example. You have a 1,2 epoxy propane. This is propane. Ito. Tatlo lang yung carbon. So this is a 1 kasi yung oxygen was attached on the first carbon and the second carbon. That's why it's called 1,2 epoxy propane. And it reacts with your base. This is your base. Ito. Yung alcohol mo, basically. Reacts with this alcohol. And then, si OH is doon siya papunta ka sa less hindered. So, hindi siya dito. Dito siya sa right. This is their product. Okay. Now you have this what you called crown ethers. It was discovered by Charles Pedersen at DuPont Company. So it's called crown ether because um, it looks like a crown. And if you name them, it has this X crown Y format. Where yung X mo, that is the total number of atoms in the ring, okay? And si Y naman, that is your total number of oxygen atoms in your ring. So like for example, ito, a compound. This is one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is an 18 crown 6. Now let's discuss about thiols. So other term sa kanya is mercaptans. So basically para siyang analog siya ni alcohol. Parang if you name an alcohol, di ba you add all at the end? So same lang siya with thiols and mercaptans. So instead of all, since yung structure ni thiol is may sulfur siya instead of oxygen. So RSH. So magdagdag instead of all lang, you add thiol. So ito, this is 1 to eth. So ethane thiol, 'di ba? Kung ang S dito is oxygen, so you have ethanol. So ito, since sulfur siya, you call it ethane thiol. So ito naman, you have cyclohexane. So si cyclohexane, meron siyang substituent na thiol group. So you call it cyclohexane thiol. So ito, this is so since you have two functional groups, so hindi na siya yung bida. So yung bida na is si acid mo. So this is what as substituent, si thiol is, you call it mercapto group. So ortho, meta. So si mercapto group mo is nasa meta. So that's why it's called meta mercapto. This is a benzoic acid. So thiols are usually prepared from alkyl halides via SN2 displacement with a sulfur nucleophile such as hydrosulfide anion. So you can form thiol or you can synthesize thiol via SN2 reaction. You're going to use yung hydrosulfide anion ito. So the reaction often work poorly unless an excess of nucleophiles is used. So, ito yung nucleophile basically. Si sulfide naman, analog siya ni ether, di ba? Kung kanina, na-discuss natin si ether is meron siyang ROR na ROR yung form niya. So, si sulfide naman is para siyang ether. Kung si thiol parang alcohol, si sulfide parang ether. Analog siya ni ether. So sulfides are named by the same rules for ether. So with sulfide used in place ni ether sa end, you use alkyl thio. So for example, um, kung substituent siya. But before that, unahin natin muna 'to. So, bale siya yung main character. So, dito, you have dimethyl since you have two methyl groups attached to your sulfur. So, you have dimethyl sulfide. Ito naman, you have your phenyl na group dito. You have your methyl group. So, alphabetical, una si methyl. So, methyl phenyl sulfide. Now, if you have two functional groups, so ito meron kang sulfide, and dito meron ka namang alkene. So, si alkene dapat yung bida. So, ito, this is what you called. Si sulfide dito is just a substituent. So, you have 1, 2, 3. So, on the third, you have your methyl or alkyl thio group. So, ito, this is methyl since methyl lang man dito. So, methyl thio. So, this is why it's called 3-methyl thiocyclohexene. Then for your last assignment, you need to name the following. So, actually, you have 4 assignments. So, you have 2 in your ether Thiols sulfides, and then other 2 from the previous video. So that is all for this video. It's only 12-minute video, very short. It's just an introduction on your ethers and epoxides, thiols, and sulfides. Thank you.